Hello, everyone. I'm Kat Steele from the University of Washington in Seattle. As I get started, an accessible version of my slides with links for further information and a transcript are available at bit.ly/imagine_mobility. Again, that is bit.ly, bit.ly/imagine_mobility. This session is focused on mobility across the lifespan. As a mechanical engineer, I spend a lot of time thinking about movement in all of its diverse forms, from wiggles to wheels to walking. All of these forms are fascinating and empowering. However, when it comes to mobility, not just how we get from point A to point B, but how we engage and interact with the world, I've come to the conclusion that our definition of what is best, what is acceptable, what is quote unquote normal is far too narrow. Today, my central message is that our mobility mindset of normal is doing us more harm than good. While as a field we have shifted to personalized care and more diverse participation-based outcomes, our assessments, environments, and expectations are still deeply rooted in perceptions of normalcy that limit our scientific understanding and our ability to support mobility in all its forms across the lifespan. When it comes to normal, we avoid using the word or come up with proxies, but it still underlies how we design, evaluate, and experience rehabilitation, especially in how we describe and evaluate mobility. It's important to remember that our current definition of normal did not even appear until the mid-1800s with the rise of statistics. Previously, normal just meant perpendicular. Adolf Quetelet expanded these statistical methods to examine the distribution of human features, describing the term the average man. But over the past century, we've seen the limitations and often deadly consequences of describing and designing based on the average man. So what does this mean for rehabilitation, and specifically mobility? I think we all know normal walking, or even walking itself, is definitively not the best solution for some bodies and environments. We need to embrace this fact and expand our visions of mobility. So today I'm going to give a few detailed examples from our work about how we have been starting to question and reimagine these assumptions. I hope you use these examples as a starting point to think and consider, how are we defining optimal movement in our community? And what is the history of these definitions? How might our collective assumptions and biases be limiting our scientific understanding? And how might these assumptions and biases be limiting our ability to support care and mobility across the lifespan? I'm going to start today in the motion analysis lab, where I began my career and where I still spend much of my time. Motion analysis technology has provided incredible value and advancements that have enhanced not only our movie watching experience, but also our fundamental understanding of how humans move and the impacts of surgical and rehabilitation interventions. For cerebral palsy, we now have almost 30 years of data from these labs that have greatly expanded our understanding of the diversity of movement and the ways the body responds after injury. While we've been able to leverage these methods to greatly improve how we evaluate and treat children with cerebral palsy, underlying these assessments, our metrics largely depend on normalcy. We systematically compared to normal kinematics, strength, range of motion, and milestones. We base surgical and rehab decisions on this perspective of normalcy to a central nervous system that is altered and functions in a different way, and that will never result in a comparable biomechanical or neuromechanical state to whatever normal is. But remember, historically, these methods made sense. Clinical motion analysis was largely developed by young orthopedists like Jim Gage, Jacqueline Perry, and David Sutherland, who were living in a pre-ADA world and leading the care and cure of diseases like polio. They were pushing technical capabilities and opening doors by reimagining participation and opportunities for people with disabilities. Now it's our turn to similarly examine our assumptions of normalcy and reimagine mobility. As a personal example, I rely heavily on metrics like the Gait Deviation Index to characterize movement. The Gait Deviation Index is a Z-score that compares an individual's kinematics to population averages, where 100 is average, normal kinematics, and every 10-point represents a standard deviation from average. This metric has been widely used and has many desirable characteristics. It distills a large amount of data into an easily interpretable metric that, importantly, is associated with function and predictive of outcomes after a wide variety of treatments, and can even now be estimated with a single markerless video. And yet we've realized that the assumptions that underlie this metric can mask important factors scientifically and clinically in cerebral palsy. For example, we can examine how GDI changes after multi-level orthopedic surgery, a common and complex procedure. We've long known that only roughly half of children who undergo these treatments have a clinically significant improvement in GDI, with the same true of other treatments like rhizotomy and botulism toxin injections. These outcomes have motivated much of our work on improving metrics to predict and optimize treatment. But we can also consider how scientifically these assumptions impact how we investigate and interpret the underlying mechanisms for how each child moves. Let's consider how these assumptions may impact a mystery in CP that has huge consequences for function and participation. Children with CP consume energy at a rate over 2 times that of their peers when they walk, which leads to fatigue and limits their ability to keep up. Reducing fatigue is consistently one of the leading requests and research priorities made by people with cerebral palsy. This is a case where comparing to normal and managing societal expectations brings the magnitude of the challenge into sharp relief. But more important for our discussion today, we fundamentally do not understand why energy is so high, and none of our current treatments consistently or significantly reduce energy consumption. If we consider again change in GDI after multi-level surgery and compare it to change in energy, we see there is almost no association. While this top quadrant, the 23% who had improvements in energy and GDI, are easier for us to understand, they likely had improvements in their biomechanics and control that made their gait both more normal and efficient. But what about the 15% who had improvements in energy but not GDI? How are they using their unique neuromechanics to find a gait pattern that is more efficient? Are there opportunities hidden in these groups to identify new, optimal ways to move after brain injury? GDI is just one example, which our team is considering closely. If we want to dive deeper, which of course, I'm an engineer, I want to, even our fundamental models are based deeply on concepts of normalcy. When we evaluate kinematics, kinetics, or generate musculoskeletal simulations, we assume your bones are a certain shape, your joints move a certain way, and that your muscles activate in certain patterns to optimize an objective function. All normative assumptions that may lead us to fundamentally misinterpret or misguide how we evaluate an individual's unique physiology and movement. Research such as the recent work by Anton Felice and Friedel de Groot has shown how when you model an individual's unique morphology and muscle properties alone, the optimal movement pattern that emerges is definitively unique and familiar, such as the model on the right here, who has adopted a mild crouch with the introduction of impaired muscle properties. These are exciting new pathways for exploring outside the bounds of normalcy. So now let's step outside the lab. This is the 30th anniversary of the ADA. Yet when we talk about creating inclusive environments and experiences, we feel a bit stuck. I'd guess this protester at the UW from the 1970s would largely argue we haven't really moved much beyond curb cuts and ramps. Our assumptions of normal movement are literally cemented into our world. Like our assessments, there are numerous opportunities to examine assumptions of normality and reimagine our environments to support mobility. Did you know it was only last year you could search real estate listings for accessibility features? And it is still not available through most of the US or on most major websites. Barry Long and partners with Northwest MLS led the charge to create additional options for new listings to specify features such as accessible approaches, entrances, or modifications for hearing and vision, making it easier for homebuyers to find what they are looking for without having to visit each home. Of course, if I search for a 3-bedroom, 2-bathroom home in Seattle in 2020, this week I see 133 properties. But if I look for an accessible home, This immediately drops to just 1 for a cool $1.5 million. These are barriers in our homes and communities, are physical embodiments of our perceptions of normal movement that clearly limit participation. But reimagining mobility means not only considering ways we can improve the physical environment, but also designing tools and technology that automatically overcome environmental barriers. So let's imagine I want to go from the Seattle Ferry Terminal to the Mechanical Engineering Building on the University of Washington campus. I do what everyone does. I pull out my cell phone, pull up Google Maps. But even though I have great public transportation options, I see that my 29-minute trip requires 20 minutes of walking. And did I mention that hill from the waterfront to the light rail has a 6% grade? What if instead I pulled up my map and, knowing my custom profile of preferred slopes and modes of mobility, it could alert me that taking a different route to other nearby light rail stations would actually be the best option. Initiatives like Access Maps and Open Sidewalk are demonstrating how we can leverage machine learning and municipal data to do just that. On Access Maps, you can create your own profile or use presets from multiple mobility modes like manual or powered wheelchairs. However, even with tools like this, you can see the path is circuitous, likely due to missing curb cuts or other barriers. If you wanted to note some of these barriers on your trip through crowdsourcing projects like Project Sidewalk, you can use Google Street View to add critical accessibility info to maps that support mobility. While these tools are helping us reimagine mobility and accessibility in our community, this is just a narrow slice of possibilities. As Buckminster Fuller liked to remind people, environments mean everything that is not me. As a rehabilitation community, we can play an active role in imagining solutions beyond the body to enhance mobility. Which brings us to expectations. My colleague Cheryl Bergstaller likes to remind me that the biggest barrier for people with disabilities is low expectations. As a society, we have deep-seated assumptions that tie how a person moves to their intelligence or other potential. As we've seen through our examples with assessments and environments, these assumptions not only present persistent barriers to engagement, education, and employment, but also underlie our narrative of helping people, quote unquote, overcome disability or fitting into a box versus recognizing the amazing range that represents a normal human state. Rehabilitation goals are often driven by desires or perceived desires for normalcy, which should not be undervalued. But these desires are also driven by assumptions, environmental barriers, and lack of narrative around a narrow normal. In a series of recent interviews with stroke survivors and co-designers, we've seen how they navigate this space and how it influences their interactions and choices when it comes to mobility and technology. We also see this in cerebral palsy from a very early age. Today, I have talked nearly exclusively about walking. While walking can certainly be therapeutic for many, it is often not functional for everyday mobility. People with disabilities view their mobility devices as opportunity, as freedom, as agency, not as a failure or last resort. But is this a viewpoint or perspective that is commonly offered? Nearly 1/3 of individuals with cerebral palsy use other options as their primary form of mobility, and walking is delayed and inefficient for most others. Yet mobility devices are not available at early ages or are withheld to not interfere with learning to walk. We know movement is critical for development, from social interactions to language acquisition. Go Baby Go, a program that provides modified ride-on cars, and other initiatives are demonstrating the important physical and cognitive advantages when a wider, multimodal perspective on acceptable or normal mobility is considered. We need to consider how devices and interventions can support development and avoid detrimental effects induced by assumptions of normalcy. We have very little evidence of the long-term impacts of walking center interventions like AFOs or walkers that are often prescribed in the first years of life. If our goal is fully participatory mobility across the lifespan, walking will not meet the needs of most people. We have to consider the full spectrum of mobility, from bespoke solutions to smart technology that can overcome environmental barriers. I'm optimistic and see amazing opportunities by confronting normalcy and reimagining mobility. So I hope that this short talk sparks a few ideas and discussions for you, especially related to how our assessments, environments, and expectations for rehabilitation are rooted in limiting perceptions of normalcy. For action items, first, consider how the assessments and metrics you use on a daily basis are tied to assumptions of normalcy. How might these assumptions be limiting or even misguiding your work? Second, evaluate your environment, from the clinic to the research lab to your daily commute. Here's the picture of my original lab. It was the old drafting room and still had the beat up 1960s drafting tables. See how many accessibility challenges you can identify. And reach beyond the physical space to the technology and tools you use in provision. How are we asking the user to adapt? Or what are we asking the user to carry? Expectations are the most challenging. Individuals with disabilities are underrepresented groups in engineering and rehabilitation. If we want to push innovation, ensure our fields benefit from diverse perspectives, and break expectations, we need to broaden participation. At UW, our Access Engineering and Access Computing programs seek to support and encourage people with disabilities to consider careers in computer science and engineering, as well as train professionals in principles of inclusive design. Building on these efforts, this spring we were excited to join the presidents of UW and Microsoft to announce the formation of CREATE, the Center for Research and Education on Accessible Technology and Experiences, at the annual Ability Summit. This is a multidisciplinary partnership reaching across rehabilitation, engineering, and disability studies. From accessible cities like the Access Maps and Project Sidewalk initiatives I shared with you today, to advances in fabrication that enable bespoke, personalized designs. This crew is busy imagining new ways to move and interact with the world. As part of this effort, we would love to keep this conversation going. So along with Heather Feldner from Rehabilitation Medicine and Disability Studies, we will be hosting a series of discussions this coming year. Mobility Reimagined will include readings, discussions, live Q&A, and plenty of time for imagining. We're so excited that our first guest will be Sarah Hendren, an artist, writer, and design researcher who will be discussing her new book, What Can a Body Do? How We Meet the Built World. To join us and learn more, please visit the same website where the slides, links to resources, and transcript from this talk are available. Again, that is bit.ly/imagine_mobility. We will have weekly questions, discussions, and reminders if you want to read along before the live Q&A this winter. So please visit the website to join us. I'll leave you today with a quote from the New Yorker's review of Sarah's new book. As Sarah writes, disability reveals just how unfinished the world really is. Her gift, perhaps, is to see that as an invitation. So I hope you also see this as an invitation to join the conversation, imagine, and explore the future of mobility unbounded from concepts of normalcy. With that, I'd like to thank NIH and NCMRR for inviting me to participate. I need to thank my students and amazing team for always challenging me to look deeper. Someday we'll get to take a new picture together under the cherry trees. And especially in preparing this talk, I need to thank my collaborators, Heather Feldner and Mike Schwartz, for their invaluable discussions. Take care, everyone, and I'm looking forward to our conversations.